My wife wants me to make this stamp for her pottery business. So I'm going to take you guys along for the ride, show the setup and everything. So here we've just basically got our vector lines. So this is the stamp. And I have to reverse it. So when she turns it over and stamps it into the clay, it creates this. So here's what I've got. I've got my material set up to the size of my block. I've got 3 tool paths over here. First tool path is nothing more than a surfacing. It's a pocket tool path, and if you see, I've got it going outside of my material boundaries. So that's just going to deck off the surface. And I'm using a 1/8 inch end mill, and it's starting at Z0, which is the top of the material, and it's going to cut 1/2 millimeter down and surface this. Now if we look at the V-Carve tool path, let's go ahead and turn this off. And here I'm using 2 end mills. I'm using a flat 1/8 inch end mill, the same one as before, to go through and cut out most of this material I don't need. And then I am using a 15-degree tapered end mill with a 0.1 millimeter ball on the end, and that is going to come in and do all of the rest of the stuff here. So that's what the ball end mill is going to do. Now all of this out here is just wasted time because there's no material, but that's just the way that the software creates the tool path, so we have to let it do it. And if we go in and we do a simulate all tool paths, there you can see it decking off the 1/2 millimeter on the top surface. Now it's going to come in and remove most of the unwanted material for the V-Carve. And there's the V-Carve, and that's what we should end up with. So I've already created all my tool paths. So now I just need to copy them over to memory stick, and the way I do it, since I've already saved these, save to file, and it brings up, and these are all stamps I've done. This is the Kira coffee. I am going to copy this folder over to, not there, my memory stick. And then I'm going to come in here, and here's my 2 tool paths. I saved the decking and the roughing of the V-Carve, since it's using the same tool. I saved those into 1 tool path. So now we're going to grab our stick and head over to the machine. So here we are sitting at the machine. I've just thrown my vise up. I've got a ground parallel in the jaws. I've got an indicator. This is one little modification I did to the machine that is worth its weight in gold. It's just a round piece about 2 inches in diameter, hole drilled through the middle, and I drilled and tapped the hole into the squeeze clamp for the spindle, just so this spud stays on here at all times. And then I can just take a regular, you can get these indicator holders for Bridgeports, you can get them off of Amazon for 10 bucks. And then I've got my indicator down here. So I need to fire up Mach. Reset. Very first thing we always do is home all. And I'm holding my phone while I'm doing this, so it's going to be quite interesting. I might just have to explain some stuff when I go to set up my zeros. So I did not mention, if we go into the setup, we can see that my 0 point, or my datum point, is the top left corner, or the back left corner, top of the material for Z. So it all happens right there. If I go in and I turn off my tool paths, you can see that my 0 points are right there at the top of the material. Alright, so we are homed. Now we have to indicate the vise in just to make sure that it's straight. As you can see now, it flops all over the place. So I just want the ball. Make sure this is somewhat snug. Okay, it is. So I'm going to take it, I'm going to touch the ball on here, and I'm going to run it back and forth and tap on this to get it straight. So since it's really loose, I'm going to tighten down this one side just to get it snug to create a pivot point. And we're going to come over here. Put a little bit of pressure on the ball. So we see that when it rotates clockwise, it means the needle's coming towards us. So we kind of need to know that. And just for fun, I will somewhat zero that. Now I'm just going to jog across. So if it goes clockwise, and that means this piece, this side of the material is coming towards us. If it goes counterclockwise, it's going away from us. So there we're going counterclockwise. And over here I have a magnetic strip with all the frequently used tooling. And I've got a old screwdriver. Just tap on that so we can see it's still going away from us, so we need to tap the other direction. And get it close to zero. Let's go back and see how far that moved us over on this side. And the reason why I'm using the parallel in here is I've only got 3-inch jaws, so I'm clamping something that's longer in the jaws for more surface area, so I get a better indication. That's all I'm doing there with that. So this is a 1/2 thousandths indicator, and that is telling us I'm 1.5 thou off. So we can see that the needle's still going in the same direction, so I'm going the wrong way. So we'll start tapping on the other side. And get it right there. Jog back over. And for the part I'm doing, this isn't very critical, but it's always good to get in practice. So there's 1/2 thou, and then it goes back towards zero. So I am going to leave that alone. I'm going to find my wrench. Going to snug that down. And without touching anything else, we're going to sweep back across. Still within 1/2 thou. I ran off the edge, no big deal. Indicating is done. We can take this off, and I just put it up here on top of my enclosure. All right, so we are done with that parallel. So we'll take it out. Now the fun stuff happens. So I have to find that edge right there. So I can either take a tapered tool, and for this job it's probably would be perfect. Put that in the spindle, bring it over here and line it up right over that corner, 0, 0, and I'm good. But I'm gonna do something a little bit more tedious, but a little bit better as far as tolerances and stuff goes. So I have a round 1/8 blank in the spindle, and I have a 0.61 millimeter thick feeler gauge. So what I'm going to do is I'm going to do it off camera because I need two hands and I'm holding the camera phone. So I am going to take and I'm going to put this in here, and I am going to jog this till it just touches this to where when I can slide this, it'll actually rotate the spindle. And what that will tell me is I am the radius or half of the diameter of this plus this off of that line. And I always, one thing I do, since I'm terrible with numbers, is I do the math that I need to do, and I'll take a Sharpie marker and I'll write my numbers down here that I know I need to work with. So 0.1587 is the radius of that tool. So I'm going to be off that, I'm going to be off that, and add those together When I come over here and I touch it and I zero there, I know that I am 2.197 millimeters off of the edge because I want this edge to be on the center line of this tool. So I will touch off there and I will touch off there with this in there, make some little minor adjustments, re-zero, then I will put my material in, put my tool in, bring it down, touch the top, and set my fixture offset. And we will get to that here in a second, but I am going to beat on this for a second, and I'll be right back with you. Alright, so here's what I've done. So you can see I've got the feeler gauge in there, and when I pull it, it slides and it rotates the tool, which means I've just got very little pressure on there. So if I want this edge, which is my 0 point, I need it in the center line of this tool. So I will just zero out the y-axis, jog it straight up, and I'm in step mode, so let me go back to continuous, jog it straight up. And if you don't know the positive and the negative and so on and so forth, we can come up here and we can push or jog the direction I want the spindle to go. I want the spindle to go to the back, so I'm going to press the up arrow button. I'm going to watch. So that gave me a positive number there, so I can now open up the MDI line and tell it to G0, Y, and I look over on my table where I wrote the numbers down. So we need 2.197. Do a really quick, so you can see I've got the code typed in there. Do a really quick check to make sure that when it moves, nothing crashes. Press enter. So now if we look, and you gotta get the perspective just right, I understand that. I am now centered over that edge. So now I will come up here and I will re-zero Y. And I am going to do the exact same, except this time I am going to come off of this edge right here. Then when I put my material in, what I will do is I will put a straight edge across there and butt my material up against that. So let me get working on that. Hopefully this video isn't long and boring. So here I am on the X. We can see that I'm rotating this. I don't have to put a lot of pressure, but it's rotating the spindle. And now if we look really close, we can see that gap that it's left in there. So this is X. So I am going to 0X. Jog Z-axis. I'm still in step, but if I hold the shift button down, it'll override it, put me, there we go. So now we need to know, is that a positive or a negative direction? So I know I want the spindle to go this direction to the right, so I'm going to press the right arrow button, and I'm going to see I get a positive number up there. So now I'm going to press enter to open the MDI line. I'm going to go X 2.197, and when I press enter, there we are, dead center of the tool. So that was X. So now I'm going to re-zero, come on, going to re-zero X. So now if I tell it to G0, X0, Y0, I am now perfectly centered over that corner. So now we have to do the Z, but I have to load material in first so I can get that. So what I'm going to do is I'm going to put the camera down, I'm going to raise this up, I'm going to put my cutting tool in here, and I'm going to put my material in. Something I just ran into, I think it's worth mentioning. So there's the broken tool that was in there that I just used as the bar. Okay, and here's the end mill that I grabbed. Pretty close. But if I stick this up in my collet, very loose. Whereas if I stick this up in my collet, I can feel the drag from the fingers. So I grabbed my calipers, and just bear with me while I do this. That's a 3mm tool. And you're probably going, yeah, so? Well, my other one was 1/8 inch, which is 3.1mm, 3.175. So could I probably get away with sticking this tool in a 3.175mm collet, tightening it down? Yes, but you run the risk of doing what we refer to as springing the collet. It means you're compressing it too far. So I have one of two options. I either grab a collet that would fit this shank, and then I have to go and rewrite my tool path because it was written for a 3.175mm flat end mill, or we put this back over here on the bar and we grab us a right size tool. So now when I stick that in there, it goes in there really tight. Let me get that finished. I just thought it was worth mentioning. One other thing worth mentioning is I got this up here in the collet, and I got the collet, I tightened it all the way down, and then I thought about this, so I thought I'd show it. I've got the, and it's hard to do one-handed, but I've got the collet nut loose. Or I thought I did. Hold on one second. See if I can bring this down so you might even see what I'm doing. So the way this works, and this is mainly for new people, a lot of people know this, but you can see that the nut's loose. I tightened it up, nice firm pressure, then I broke it loose. I can spin it, but the tool will not, well, yeah, I can pull it out, but it's hard to pull it out and push it back in. So on these collets, you spin that nut till it stops spinning again, then you have to put the wrench on it and pop it loose. Now I can, one of these days I'll actually get some kind of equipment to do this. So what I was trying to get to is when you tighten one up, and then you break it loose, and then you unscrew it till it tightens back up, you still can't pull the tool out. So you have to put the wrenches back on it, pop it loose again to get it to pull the collet out of the actual taper of the spindle. All right, so there we have that. And let me go ahead and jog the Z-axis up. So here's the piece of material that I'm going to use for this project. It is saw cut on almost every side. So it's not square by any means. But I also can't just chunk it in my vise and go to town on it. Because it sits lower than my vise jaws. So I can't machine off this top surface without running into my vise jaws. So that's where parallels come in. And I don't really have any for this vise, but I've got some big ones. And what I like to do is take this guy, run your hand around all the surfaces down here, make sure there's no dirt, dust, swarf, chips. And I am going to lay this guy down. Then I'm going to put this guy right on top of that. Now I'm going to take this guy, run it across these two surfaces, because that's the one I indicated on. I'm going to push it over, down, and I'm going to stop the camera, and I'm going to grab my vise handle, and I'm going to crank that knob. Now, because my material is sawn cut and it's not square, things lift and move, and it's not going to be a problem for this part. But for example, if we look right down, you can see where it bows up off of the parallel, but my parallel's in here tight. I can wiggle it and probably get it to pull out, but what we'll do is let's jog this out of the way. My trusty hammer. As Adam Savage says, anything's a hammer. Give it tight down, and we're there. And that will work. So now we have to find the top surface. And I'm sure it's wavy and not square either. But what I'm going to do is I'm going to hit about the middle. And we are going to take our technical difficulties. I lost my shim. Be right back. Couldn't find my shim because when I did that, it fell down over here. So we know that this shim is 0.61 millimeters thick. So if I stick that on there, and it went away from me too much. Get about the center, and I'm gonna go cycle jog step to 0.1 millimeters. We're gonna step down. What I'm looking for is drag on that. So I saw it move. That's actually pretty damn close. So knowing that, if this is touching the top surface, and this is a known thickness, and this is touching this, then all we have to do, we can do it one of two ways. We can come up here, 0Z, take the shim out, tell Z to go negative 0.61 millimeters, and then re-0Z again. Or we can just come up here and tell it that it is in a positive number because it's off the top surface, 0.61. Which if we look, that was the thickness of our shim. We told it it's now 0.61 millimeters above the top surface. Now I need to set a fixture offset, so I'm going to tell it to G0, X0, Y0 in the MDI line. So now we're over that corner. Now I'm going to tell it to G0, Z0. So we are 0, 0, 0. Tool is sitting over the edge, over that corner. Material's not straight, so it's not exactly perfect, but for this it's going to be fine. So if this is our work coordinates 0, 0, 0, I need to set this as a fixture so I can refine the tool length using the tool probe. So we're going to go to Tools and Fixtures, and I am going to use Fixture 2. Now when I did that, when I told it that I was going to use Fixture 2 right here, all my numbers changed because it was originally using Fixture 1. So if I come over here to Fixture 2 and I just zero all, I'm back to where I started. Now I'm going to set fixture. It's going to need a probe. This is pretty boring, so I'm just going to go ahead and pause. Okay, it's done probing and it set my fixture, which is these numbers here. We've got our first tool in, so now we need G-code. Slap this down here into my dusty computer. Cura Cafe, cut, come over here, load G-code. I've got a folder in here. So the way I do it is right off the C drive I create a G-code folder. Then I put subfolders in there for the projects that I'm doing. So here's Chris's stamps. I'm just going to right click anywhere, paste that. Show all files. We don't need this. So there's the 125 flat surface and clear. That's the tool that I want. All right, so now we can see that we have the magenta crosshairs, which is the center line of the tool, and we can see what this is going to do. So now I'm going to, just for argument's sake, get that down here. Give me some RPMs on the spindle. I set it for 10,000. If we look in the code for this tool, it's gonna go to 12 thou. All right, so now we grab everything that we don't want to get all our chips all over out of the enclosure. Hang the bane of my existence back up. And click cycle start. Let's see what happens. We are doing the surfacing pockets. Alright, we can see where it's not cleaning up right here on this corner. So I'm going to feed hold. Alright, the machine stopped, so I'm going to click stop. You never just want to go stop because there's a buffer running. You feed hold, let it finish running out the buffer. Stop. Now I'm going to rewind that tool path. And what I'm going to do is I am simply going to come over here somewhere. I'm going to type in G0, Z minus 0.5 because that's our deck height that we cut it down to. Now I'm going to re-zero. Okay, I'm going to bring the Z up off the top surface a little bit. Send it to X and Y 0 again. Now I'm going to send it to Z0 and reset the fixture offset. We're using fixture offset 2. Set fixture. Yes. Obviously this is going to be boring, so I'll bring you back in a second. Alright, it just got done probing. I got a new value of my Z because of the Z0 difference that we made it go down. And I am just going to simply rerun this code. So we're going to click rewind, make sure it's all the way at the top, cycle start. And this is why I made that bounding box bigger than my material. Otherwise it would have been stuck and I would have had stuff in all four corners. So right now it's just cutting air, not a big deal. Now it's going to start making some noise. You see why I backed down the feed rate override? That was exciting. Didn't quite get these off, but that's not a big deal. So now what I'm going to do is I'm going to load up my second G-code, the tapered end mill. I am going to put you guys down for a second while I make a tool change. Tool change is done. I've never used this tool before, so hopefully we don't break it. That's probably not going to work. There's the old one. So now we need to probe it. Come over here, make sure there's nothing on the tool probe. I'm probably going to end up breaking this. I forgot that it's a profile tool, not a tapered ball or mill. Alright, let's take a look at, since I don't know what it's going to do, we're going to take a look at the G-code. And it's going to go at 18,000 RPM, feed rate of 500, so we're probably going to override that and slow it down. So, cycle start. Feed rate override. So this is wasted cut because of what it does. And we're just going to let this go. I'll bring you back when we have a result, one way or another. 10 minutes, 42 seconds later, we have a result. Don't know what it is yet. The tool didn't break. Take a toothbrush and clean this off a bit. I think we have a good part. What I am gonna do, I can see some areas that are bad. That's gonna suck. So white on white is obviously hard to see. So what I may have to do, what I'm looking at, are these little lines right here, which is obviously not coming through. But if we come back to our CAD, we are looking, so for some reason it's got two lines in here, which is not that. So let's go back and check our preview. Yeah, sorry about that. Y'all have no idea what I'm talking about. And if anybody's wondering, I'm using Vectric Aspire for this. So in my part, it looks like I'm seeing two lines right here, but I could be mistaken. So what I'm looking at is something, there's a wall right there and right there. Maybe because my parameters were off on this tool a little bit. Other than that, I think we're good. So what I'm going to do is I am just going to rewind and just rerun this G-code. See what happens. I'm going to run it at 100% so it's faster. So we'll let that run and see if that solves any of our issues. Yeah, so we've actually got some remnants here, and I figured out what it was from. You can see a little half moon there and a half moon there. And what that actually came from, when I set my tool up, I set the parameters up wrong because I thought it was a tapered ball end mill, which had a little bit larger diameter. So we are getting, when it does its rough pass here, okay, it cuts this, then it thinks this material is gone here, when in actuality it's still there because when I ran the finish pass, the tool was just a little bit smaller. I can probably break it out, so it's not terrible. But let's go ahead, in worst case scenario, we can just rewrite the tool path, zero off of this surface again, and redo it. So I'm going to go ahead and pull it out, and I'm going to blast it off. Autofocus sucks. Oh, so I've got a water blaster that I'm going to use to see if I can remove the rest of this swarf material with. So I'll be back. Did a little bit of cleanup, and nothing too serious, nothing to even worry about. So it's hard to see, but I went and got a piece of clay. We're just going to give it a good little press and wiggle. Maybe a little too much of a wiggle. I think I pressed it in there a little too hard, so let's go ahead and flip that over. I'm going to put some water on this so it doesn't stick, but I need to get that clay out. And to do that, I'm going to use my little water blaster. I know you guys can't see. But I just water blasted it and it blew all that stuff out. So let's go. Normally I think she puts some sort of cooking spray on these so they don't stick. I think we have a winner. Let's erase that real quick. Clay is so much fun to play with. But just from fumbling with it, and this clay's a little hard, but there you go. We have a stamp.